For this lesson, I just want to look at a few examples of transformations in general, so combining everything together. The function I've written here doesn't have a formula to it, but the way we're going to figure out what it looks like is by moving a couple of points around. So I'm going to mark, here's negative 2, 2, 0, 0, and 4, 4. If I know where those 3 points go on this graph, I can then sketch in the rest of the equation around it. So I'm going to list what this function does in order. So I see there's 3 things happening. And again, I'm moving within the function first, and this is changing the x's. So I see a 0.5x. So this is going to be some type of stretch, and it's the opposite of what I would expect. So I'm not going to take half of the x values. In fact, I'm going to double them. So that's step 1. It's to double the x values. The second thing that happens is, well, I see multiplication by 2. Now everything else is outside of the function, meaning I'm changing the y values. So this is going to do what I expect. 2 times the y value is going to double the y value. And then the last piece, this plus 1, again, it's outside the function, it's changing the y value. This means go up 1. So with this list, I'm going to go to my original graph, and I'm just going to go through point by point and see where it ends up. So let's see. I'm going to start with this one here, negative 2, 2. I know I'm doubling the x value. It's negative 2, meaning it goes to negative 4. Then I'm going to double the y value, which is 2, so it goes up to 4. The last step is for it to go up 1 place, and that's it. The final location is going to be negative 4, 5. That's what this function does to this 1 point. Double the x, double the y, added 1. Okay, continuing. Now I'll do the same thing with this point here. All right, I'm first going to double the x value, which is 0. Okay, so it doesn't go anywhere because 2 times 0 is 0. I then double the y value. Again, the y value is also 0, so it does not go anywhere. But the last thing is to add 1 to go up 1. So I end up at this spot here. So it's very possible that the points you have, they might not be affected by some of the steps, but that's okay. Its final spot is 0, 1. And for the last step, okay, this is 4, 4. So if I double the x, it goes out to 8. If I double the y, it also goes up to 8. If I go up 1 more, it's now at a value of 9. So that's 8, 9. So there's where the 3 points end up, and every point must follow in the same way. It has to resemble the graph that I start with, so this is my final equation. And we can ask ourselves if this makes sense back to the original function. It doubled all the x's, it doubled all the y's, and went up 1. And if I check out the original graph, it certainly does expand out left and right, so you're doubling the x's. It's definitely taller because you doubled all the y's, and it certainly moved up 1 as well. And that is it for this example. So we're looking at the same graph in example 2, but this time I want to see what negative f of x plus 5 minus 2 does to this graph. I'll still use the same 3 points, and I'll list out the different things in this function. So in order, again, working inside the parentheses, okay, we have x plus 5, that's only changing the x's. It'll be the opposite of what I expect. So this is actually going to go left 5 places. Okay, next will be multiplication by this negative. Okay, that's a negative 1 to the y values. That's going to reflect all of the y values over the x-axis. You can actually just say reflect the y values. They would have to go over the x-axis if you're changing a y value. And lastly, there's this minus 2. You're subtracting 2 at the very end, and that's to the y value, so I know that's going to mean that means go down 2 places. Let's see what that does to this original graph. So again, you can start with any point you like. I'm going to choose this one here. I'm first going left 5 places. So that's going to go to -7. I'm then going to reflect the y value. The y value is 2, so it goes down to -2. And then it goes down 2 more places. So we end up at -7, -4. All right, so continuing, here we have the point 0, 0. It goes left 5. I'm now reflecting the y value, but it's actually on the x-axis, so this does nothing. -1 times 0 just stays at y equals 0. But if we go down 2 places, we end up here at -5, -2. And then for the last point here, we're going 5 places left. Reflecting a y value of 4 goes to -4. And then down 2 more goes to -6. So that's -1, -6. So this is the graph. So it still resembles the shape of the original equation, but this time it's upside down, but that's great. Anytime that you reflect a graph, it should be some type of mirror image of that thing. This definitely went left 5, flipped upside down, and then went down 2 places. And one final example, y is equal to 0.5 times f of -x plus 3. So let's see, for this function, again, it's 3 things that are happening. All right, the -x inside the function, okay, that's changing my x values, so it's reflecting the x's. So I'll just put reflect the x values, whatever note that you need to remind you what to do. Then we have this 0.5. Now, again, everything else is now outside of the function. We're taking half of the y values. So you could write this however you like. Maybe just say, multiply the y's by 0.5. Same thing as saying dividing the y values by 2. And the last thing is the plus 3 at the very end, and that means up 3 places. Okay, so this is up 3. Again, using these 3 points, you can use any points you like. I just think those are the 3 most obvious ones. Let's run through it. Okay, starting here, I'm going to reflect the x value. So it's currently at -2, so therefore it goes to +2. I then multiply the y value by 0.5, or divided by 2. It's at 2, so it drops down to 1. And lastly, I go up 3 places. 1, 2, 3. This is it. 2, 4 is where this point ends up. All right. Now, if I go to 0, 0, all right, I'm reflecting the x value, but the x value is 0. It's right on the axis, so it does not go anywhere. Now I multiply the y value by 0.5, but the y value is 0, so okay, this step doesn't do anything either. It stays as is, but then we're going up 3 places. 1, 2, 3. We end up at 0, 3. And for my last point, okay, it's at +4 for x. It reflects to -4 for x. We then multiply the y value by 0.5, so it's currently at 4. It drops down to 2. And then we go up 3 places. This is -4, 5. And if I connect these points, this is my graph. So this thing has reflected over the y-axis. The distance between the largest and smallest y values has decreased too. Like it's just a distance of 2, whereas the original graph had a distance of 4. But that makes sense. We're taking half of all of the y values. And this thing certainly has shifted up 3 places, so this is the final graph of my new function.